This video introduces uncertainty in design decision-making. Decision is an allocation of resources to achieve a desired outcome. It exists everywhere in our lives. In particular, a design process cannot go without making decisions. To make a design decision, first, the decision maker needs to define the decision problem, which includes objectives, criteria, and alternative courses of actions. Then the decision maker uses a model of reality to predict the outcome of an action. Each outcome is characterized by its attributes. The payoff of an outcome depends on these attributes and the decision maker's preferences. At last, the decision maker will select the action with the most desirable outcome. The three basic elements in a decision are alternative courses of action, outcomes of the actions, and payoffs. Back to the process of decision-making, uncertainty could be found in every stage. When framing a decision, the decision maker may not know if the frame captures the decision situation at hand, and also may not know if all possible courses of action are considered. When evaluating the outcome of an action, the decision maker is often uncertain due to a lack of knowledge or inherent randomness. When facing uncertainty, the decision maker cannot select the action with 100% confidence that guarantees the most desirable outcome. But the decision maker can select the action with maximum probability to achieve the outcome. With this aim in mind, it is necessary for the decision maker to know the potential uncertainty in the decision-making process and how to cope with it. Uncertainty has been conceptualized in many ways, but the core idea is consistent. According to decision theory, certainty is when the decision maker knows everything needed to select the action with the most desirable outcome. Then, uncertainty is the gap of what the decision maker presently knows and certainty. Uncertainty can be divided based on whether it is reducible. Irreducible uncertainty is the gap between certainty and the perfect state of knowledge after eliminating reducible uncertainty. Studies on uncertainty in making design decisions have proposed many taxonomies of uncertainty. Basically, uncertainty was categorized either by its causes or its nature. For cause-based taxonomies, uncertainty can be classified into three types. Aleatory uncertainty. It refers to inherent randomness of natural phenomena or process. It arises from its intrinsic variability that cannot be reduced unless we change the phenomenon or the process itself. Epistemic uncertainty. It is a possible deficiency in decision makers' capability of choosing the most desirable course of action due to lack of knowledge. It is reducible by collecting data or acquiring knowledge to improve predictive models. The third type is uncertainty due to human error. It is defined as the deviation from acceptable practice, which are also reducible to some extent. However, there is not distinct boundaries between different types. Overlap exists. For nature-based taxonomies, studies consider uncertainty as incompleteness of required information and therefore a lack of knowledge. Relevant studies classified uncertainty according to the cause of knowledge deficiency and the available information. To manage different types of uncertainty, we need different information. To reduce uncertainty due to a lack of knowledge and creativity in framing decision, linguistic information from experts is helpful. To quantify aleatory uncertainty using probability distribution, experimental observations are required. When samples are sufficient, the designer can develop a probabilistic model to calculate the probability distribution of output variables. In case of insufficient data, a first principles-based model for the probability distribution could be used to estimate the parameters. If the data is very limited, additional information such as expert opinions together with principles of uncertainty can be used. Epistemic uncertainty can be characterized by intervals or linguistic information from experts. For the epistemic uncertainty in predictive models, It can be characterized by combining subjective information and experimental measurements. Based on expert judgment, a prior probability distribution of the parameters can be estimated using the limited samples and then updated using experimental data and Bayes rules. Results from sampling theory are also available for modeling uncertainty in the values of parameters of a distribution. To quantify the uncertainty due to human errors, sampling data can be used to estimate the frequency of occurrence of execution errors. Uncertainty is an important factor in making design decisions, which may have an impact on the final decision. Therefore, decision makers need to minimize the reducible uncertainty and manage the unreducible uncertainty. For this purpose, it is necessary for decision makers to understand all important types of uncertainty in each stage of the decision-making process and the information and the methodologies of coping with each type of uncertainty. Last but not least, as design conditions and process vary greatly in different fields and projects, the designer needs to do uncertainty analysis case by case.